Perhaps there is both dark matter and dark energy. But this is not necessary. The rationale for these magical elusive substances is based mainly on two galactic phenomena. The first is the excessively high rotation speed of the edge stars in galaxies, and I realized that in all of them. And the second phenomenon is the expansion of the universe, which is manifested by the movement of galaxies away from each other, sometimes with increasing speed. It is these two phenomena that astronomers associate with intangible and invisible dark forces. But, in my opinion, there is nothing in these manifestations of nature that contradicts Newtonian physics. And I will give arguments in its defense. So, the first phenomenon. The rotation speed of the edge objects of the galaxy is too high, despite the significant distance from the center of the galaxy. That is, they say that the Newtonian mechanics of gravitational rotation of planets around the central star does not work in galaxies, because according to Newton, the further from the center, the slower the rotation. But maybe we should not discard the laws discovered by Newton, but imagine in what special conditions these laws will manifest themselves. So the rapid rotation of the edge stars in the galaxy is easily explained by the obvious difference between the solar system and the galaxy. In the solar system, the sun and the planets actually have point centers of mass, and all the planets are attracted to the maximum extent to the sun, which is incomparable in mass. And it is clear that the farther the planet is from the sun, the less the force of attraction between the sun and the slower the planet rotates around it. It happens completely differently in galaxies, where the forming force is the attraction of stars among themselves, that is, between all the stars in the galaxy. In galaxies, the force of gravity acts on a star not from the point center of the galaxy, but from all the stars in the galaxy, which of course can be reduced conditionally to the calculated total center of mass of the star cluster. But I repeat, conditionally. Let's imagine how such mutual influence occurs. Let's draw a galaxy in the form of a circle or disk. Let's take a star located near the edge of the galaxy, held in a circle by centripetal gravitational forces. I think it is clear to us that the stars located outside the star in question also attract it and create a force directed opposite to the center, centrifugal force. Which, in turn, is compensated by approximately the same number of stars from the center of the galaxy. Therefore, an area of mutual neutralization of centrifugal and centripetal forces arises. This zone is shown in green in the figure. And it minus part of the total gravitational potential of the galaxy. But in this case, this zone is small. Now let's see what the neutralization zone is when the star is closer to the center of the galaxy. Figure on the right. Here, the zone that minus the centripetal gravity of the galaxy is much larger, which means that the gravity holding the star consists of a smaller amount of the galaxy's mass, the centripetal force is weaker and the star will move along the galactic circle more slowly than the one at the edge of the galaxy. That's all. The phenomenon of rapid rotation of stars at the edge of the galaxy can be explained by the usual gravitational effect, but not of one massive center, but by the sum of a large number of stars. Where the star will be affected by both the centripetal and centrifugal forces of neighboring stars. And dark matter has nothing to do with it. And supermassive black holes are not necessary here. It seems that the core of the galaxy can contain a large amount of gas and dust, which form the central thickening in disk and spiral galaxies, and massive objects have shifted to the edge. Spherical galaxies seem younger, where the orbits of the stars have not yet lined up in one plane. After all, the construction in the plane occurs under the influence of the most massive stars. Probably, the orbits of all lighter objects tend to approach the plane of the orbit of the largest bodies. The next phenomenon. It is called the expansion of the universe and is expressed in the scattering of most observed galaxies, in the increase in the distance between galaxies, and, in some cases, with acceleration. In my opinion, this fact should be explained by the movement of galaxies in orbit around some center of masses, most likely around a cluster of galaxies. Let's turn to the diagram. Conventionally, 4 galaxies on it, the first is the heaviest of the 4, the second is much lighter than the first, having approximately the same speed of movement as the first, the third is the slowest moving, and the fourth is the fastest. The orbits of these galaxies have not become completely ordered and completely stable in just some 15 billion years of their existence, because it is likely that a galaxy can make even one revolution around the intergalactic center of mass of a galaxy cluster in hundreds of billions of years. Let's look at 4 galaxies with different masses and speeds, located, for now, close to each other. And imagine how they will behave further. The galaxies will scatter naturally and without the influence of unknown forces, moving along an orbit under the influence of gravity emanating from the supercluster of galaxies. After some time, their speed will have an effect. After all, our part of the universe is probably at such a time point in development when all the galaxies have already distributed themselves by speed, when there are no more galaxies catching up with each other. Fast-moving ones are increasingly running away along the course of movement, and slow-moving ones are increasingly lagging behind, like athletes runners in ultra-long distances, but not a single runner has yet made even a lap, has not made a single cycle of this marathon. Galaxies with a higher speed will have a flatter orbit with such movement, as well as more massive ones. Massive galaxies will have a flatter orbit due to inertia. Their mass is still quite noticeable in comparison with the mass of the center of attraction. This means that the fastest and most massive galaxies will move away from other marathon runners in the lateral direction. And all of them will also increase the linear gap. Now let's think about why the acceleration of the recession of galaxies can occur. For example, the movement to the perigee of an elliptical orbit around a supergalaxy can accelerate this process. Although it is possible that galaxies move, in some cases, not around, but towards each other, to merge, under the influence of ever-increasing gravity as they approach, like the Milky Way and Andromeda. They are getting closer. For this reason alone, not everything is so clear-cut. And dark energy, it seems, has nothing to do with it. Thank you if you watched to the end. I admit that I can be wrong, so I will be grateful for comments and remarks. Perhaps we'll want to argue, but this will also be interesting. As they say, right?